The tools we have here, cordless drill for removing screws and fasteners from any parts of the case. We need a crescent or a 7/16 wrench to bite onto the 1/4-inch axis. You'll also need a set of adapter hoses or an adapter valve, and it comes in 3 different forms. You can either use this 3-inch stub, which is the preferred method, and what this allows you to do is attach to the Schrader and close the system when you're pulling your vacuum, and then when you go to pull that hose to charge back up, you have no loss from your hose whenever you are pulling that line from the system after you've charged it. This can also be accomplished with a slightly larger piece, there's a little bit of loss when you disconnect the hose, but it's still within tolerance. And this can also be achieved by a more standard evacuation hose, which has the same lead on it and the valve built in. And this will also allow you to hook up to, if you wanted to use gauges on the backside, you could do that. So you could pull a vacuum from both the suction and the liquid side. You'll also need an essential item of a fan to help vent any charge that leaks out under the case. Once you open the system, you always need to have a fan running. And the best approach is to remove 2 panels on the case so that you can move air through the case from one side into the next. It's essential to have this fan running before you start so it dissipates any charge that leaks into the atmosphere. Last piece of equipment, if you're opening the system, you're obviously going to need to evacuate it down. There's a bunch of different styles of evacuator pumps. So most likely what you're probably going to run into in the field is a smaller evacuator pump like this, a little portable unit, rather than this big wheel around one. And also you'll probably see a gauge more similar to this. And those are the tools required to make a change to get into the system. So what I've done here, if you have a problem with the system, you obviously need to take some panels off to get to it. Taking this first panel off, I have access to both the suction side and the liquid port on this case. Now, before I go any further, I'm going to take another panel off here so that I can start venting air crossways through the case to make sure I've got good airflow and that everything is breathing underneath and there's no charge storing up in any one corner of the case once I start opening the system. So I've already taken the screws off, 4 mounting points. I just pop this panel off. I'm going to set this aside. So now I've got this open. I make sure that my fan is positioned in a way that it's moving air through the case and it blowing all charge that leaks out away. Turn it up to setting 2. I usually run it on setting 3 just to be safe. So what you see once you open the system is you're going to see the high side liquid pressure tap, Schrader access, and the low side suction access. Now what I've already done is I've installed this 3-inch valve. I've installed one of these onto this system. It's key to have that there because this allows you to disconnect from the system once you've charged it with the minimum loss possible. If you need to vent the charge from a live system, you obviously have to shut the unit off, turn your fan on, and then once you have after valves on or a similar hose valve, all you do from there is you do a very slow vent. And it's best to do it, you have a set of gauges on there. You can kind of see how much pressure, how slowly you're venting it. And the idea is just to do a very slow vent. You want to do it as slowly as possible so that to jump 150 grams, it probably takes 10, 15 minutes. So this is a hydrocarbon refrigerant. So you are allowed to vent this to the atmosphere. You can see that I have pressure. I'll open it here. Now there's a lot of redundancy in the valves, but I'm just doing this so you can see. Make sure my fan is pointed directly at what I'm doing, so I immediately dissipate any refrigerant that's coming out. I just crack the valve, and you can hear a little hiss. And then I just like to look and see that my needle is very slowly moving. I don't like to have it go too fast. You don't want to dump too much at once. You always want to vent slowly so that it dissipates. And then you let it go until it runs out. And that's what it would take to vent the system with whatever remaining charge is in there. So once you have the system vented, then you can go through and evacuate it. So you cannot charge a partial system because you don't know how much is in there. You're not going to have any way to know how to get it back to the correct level. If you want to pull a vacuum from both sides, you can install on both. Now, whenever you go to install this, there's going to be a little bit that spits out, which is why it's essential that you have your fan going already. You have to do this when the system is off. You'll have lower pressure on the high side. And there we go. A little bit of a spit, nothing too major. The fan's going, it dissipates it all out immediately. And now I've got an access point right here. You could either connect a single source and charge directly from the bottle through a single port. You have a more elaborate setup where you can pull a vacuum from both sides, remove these, and then hook your bottle up and charge through a single port. You would hook it up just like normal. Your liquid side onto your liquid port. And then for the suction side, I'm going to use this. And now note, this evacuation hose does have the built-in valve on the end. So basically, the way I'm showing you right now is a redundant setup. You can do it either with just this piece, or ideally with just this piece, but what you're going to see is these two in line with each other. I'm connecting the suction line so that I can pull a vacuum from either side, just so it evacuates faster. That's all that this is achieving. You could do it from one side, it's just a little bit slower. So now that you've got your hoses set up, the last step is to connect your vacuum. And now you've got your system hooked up, ready to turn your evacuator pump on. And you'll be pulling from both sides to evacuate the system faster. You could alternately bypass gauges completely. This should be a simpler setup. So these are just some examples of the propane bottles you may see in the field. This is roughly a 5-pound bottle, and this is roughly 226 grams. Different options available, but these will probably be the two common ones that you'll see. Anytime you're charging any refrigerant, you'll need a refrigeration scale to go with it. So we recommend a 2-gram resolution. What we're going to do now is charge the system. I'm going to use this assembly that I've got. Do this two ways. You can bypass the gauges completely. As long as you have these small stubs on here for valves, you can isolate the system so that you can take this vacuum off at any point. And now you can charge with the shortest hose possible to reach this valve. Go ahead and set my refrigerant on the scale. Connect. Then what you'll be able to do from here, you can connect up to your valve. And again, make sure the fan is still pointed there so that anything that happens if there's any type of leak, still dissipating it. Now what you will need to do at this point is bleed this hose, which you'll have to crack the bottle, or in this case I can crack this valve. And then I'm going to leave this to where it's a little bit loose. And then I'm going to crack my hose. I'm going to crack this valve here. There we go. Now you don't want to vent too much here because this is liquid propane coming out. So you want to be very, very cautious of how much you let out. Always have the fan running. So now you tighten that up the rest of the way. Now you've got your line charged all the way through. You may want to turn your fan down and direct it more at the joint rather than the hose so that there's no air actually blowing on the hose. And if you have zip ties, it's a good practice to fasten this to the post so that there's no movement up here. Two possible ways to do it is you could zip tie this to the post, or in a pinch, you just got some tape. You can tape this nice and tight. And the key is that you just don't want any movement. You don't want any movement happening here in the hose. And the reason you don't want that is because once you turn this on and you're charging, you want to do all of your charging at this point. So that when you crack this valve, you'll see you have much better control than whenever you're here and you've got the wiggle in the hose and your scale reads. You don't have to work at this valve, and you don't have to work at this valve, because when you touch this, your scale will always be moving. If I'm working around here, now that I've got this fastened, I have a much more stable readout on my scale. And one thing you'll also want to note is that all of our R-290 charges will be working in grams rather than pounds. Change this over to kilograms, and that's what I would work with. I'll slowly crack this valve. I will wait for charge to slowly trickle in, and then I'll let it set. And let's say I want to add 40 grams to this case. Slowly crack this valve, and there it is. Now this is going pretty fast. You predict where it's going to go. You get the pattern of how much you're adding, 32, 34, 36, 38, 40. If you go over the design charge, revent the system and recharge it back. Because if you go to vent, like if you go to vent from either of these ports you have on here, you don't know how much you're letting out. So you could very easily put your system back into an undercharged situation. So it's critical that you try and take as much variation out of the reading as you can by attaching the hose here, by using the valve here, because then the secondary point to this is now that you have a critical charge in here, you can disconnect right at this point, and everything you've measured has crossed at this point. So when you take this off, there's minimal loss. Whereas if I were to use this hose, I would have this much. Now this is also an acceptable amount of loss, but you would lose this from your system once you disconnect. Anything beyond this is going to affect the performance of the system, which is why you don't want to use just a direct connect length hose like this all the way up here. Now you would be measuring that from your bottle. You have that much in that's affecting your reading, so you really don't know how much you've got in there once you take that off and vent whatever's in this hose. And the last step here, now that you've got this charged, now I'll close my bottle and I'll take this off. Once I do take this off, there's two ways I can go about this. I can either take it off here right away, or I can take it off here. I'll go ahead and rip my tape. Either way you do it, you're gonna have charge that's in your hose trapped there. So I'll take it off here. Now when I do this, I've got this whole line. I just crack it slowly because it is going to bleed and my fan is going. I do it very slowly and I just wait for all the charge to dissipate. My valve is still shut. And note that it is liquid in this hose, so that's why it's important to use the shortest hose possible, because it does take just a little bit to vent. Now it's empty. There you go. Now you're disconnected from the system. So once you have everything disconnected, then you just reinstall your panels.